Okay, let's look at the homework 18, problem number 1. Alright, so we're gonna just evaluate both sides of this equation here separately to see if we can get the same values. Alright, so let's do that. Alright, so let's look at the left hand side. So left hand side, right, is going to be equal to, right, so this is a triple integral, so we have a triple integral over the ball, so it's actually a unit ball with radius 1, so it's going to be tau. Alright, then the divergence of v, so partial with respect to x is 1, plus partial with respect to y would be 1 again, and partial z with respect to z would be 1. So that's 3 d tau. Alright, so this is just 3 times the volume of tau, which is the ball with the radius 1. So this is just going to be 3 times, right, 4/3 pi, r is in this case 1 because the radius is 1 cubed, right? So we can cancel 3 here and 3 there. So it's going to give you, so left hand side gives you 4 pi. All right, so let's do the right hand side. Right, so right hand side is a double integral over the boundary, so that's going to be the surface of the unit sphere. Right, then v times n, we have to come up with n. Right, so we are looking at the sphere, so let's see, so we have to, so I'm going to call this guy right here x squared plus y squared plus z squared, so I'm going to call this guy f. Right, so in order to find the normal vector, unit outer normal vector, we look at the gradient of this guy. So it's going to be a gradient of f is going to be partial this guy with respect to x is going to be 2x, comma, partial this guy with respect to y would be 2y, and partial with respect to z would be 2z. Right, so in order to find the normal vector, actually I'm going to just pull out the 2 because 2 times x plus comma y comma z. Right, so the normal vector is unit normal vector would be, so I'm going to take out 2 because it's just a multiple by 2. Then I'm going to divide, so n is going to be divide x comma y comma z by its magnitude, so it's a square root of x squared plus y squared plus z squared, so that the length is 1. Right, so let's do that. So v is x comma y comma z, right, then multiply by and x comma y comma z over square root of x squared plus y squared plus z squared, and with the surface area element. Right, then multiply out, you will see that this is going to be simply integral over the surface of the sphere. So x times x is x squared plus y squared plus z squared divided by square root of x squared plus y squared plus z squared d sigma. Right, but here on the surface of a sphere, unit sphere, x squared plus y squared plus z squared is actually 1, right, because that's the equation. On the surface, x squared plus y squared plus z squared is equal to 1, so that's 1, and this is 1. Right, so we are just looking at this is just the surface area because this is going to be 1 of the boundary, the surface of the sphere, which, as we know, 4 pi times r squared. So 1 squared, which is going to be equal to 4 pi, right? So we can see that left hand side, so therefore combining these two guys, so therefore left hand side and the right hand side are equal to each other, because we get 4 pi on the left and 4 pi on the right. All right, that's it. I hope that this was clear.